and welcome to video 9 for Math 123. We're halfway through our material here. In video 8 we looked at probability, flipping a coin, tossing a die, pulling a marble out of a jar, which is the common one for the praxis exam. In video 9 we're going to look at the idea of what's called with replacement or without, and it's kind of building on that marble idea. So if I had that jar of marbles and I took one out and then put it back in and picked out another marble, how does that affect the probability versus just picking out marbles until I run out? So let's look at that. And this is known as with replacement or without. And so when you're doing the praxis exam, when you're doing your midterms, when you're doing the homework, pay close attention to what is the problem asking. Is it saying that you're putting the marble back in the jar, or you're just picking and going from there? So let's look at that same example that we just had. So we had the jar of marbles. We had 4 red, just as a reminder here, 5 blue, and 2 white. So the first thing we want to look at is what is the probability of picking a red putting it back. So this would be what? This would be with replacement. So we take a red marble, we replace it, we put it back in the jar, and then pick a white. So in the previous example, we were just picking one marble. Is it red? Is it white? Is it blue? But now we want to know, okay, I pick a marble, what's the probability it's red? I put it back in the jar, mix them all up, pull out another marble, is it white? So that probability then, did I do these? Oh, I guess I didn't really work them out. Well, let's work it out. Well, yeah, we'll work it out. Why not? Example, some practice here. So we pick a red, so we want the probability of picking a red. We put it back in, and then the probability of picking a white. So it's actually not plus, it's what? It's times. Because it's and. Pick a red and pick a white. So probability of picking a red, well, there was what? 11 of them. And the probability of getting a red, as we saw in the previous example, 4 out of 11. Now I put it back. Now I want to pick, oh, I did do this, okay. Now I want to pick a white. So now it's like we're starting all over. There's still 11 marbles in the jar, but now only 2 of them have the possibility of being a white. So we multiply 2 fractions, so we just multiply across. 4 times 2 is 8. 11 times 11 is 121. So there's an 8 out of 121 probability of picking a red, putting it back, and then picking a white. Now, what if this said instead, what is the probability of picking a red? Don't replace it. So we're not going to put it back. Then pick a white. So it's what? It's the probability that I picked a red with a full jar which had 11 marbles in it. So probability I pick a red with 11 marbles times the probability that I pick a white. And how many marbles are in the jar now? Well, only 10, because I pulled out a red one already. So this is what? Probability of red out of the 11, that's 4 out of the 11, times Probability of white, well, there's still 2 white in the jar, but this time there's only 10 marbles left because I didn't put that red one back. So now we multiply across, we get what? 8, 11 times 10 is 110, so 8 out of 110. So the first example, 8 out of 121. Now, because we didn't put that red marble back, there's a higher probability we can get white. So this probability is a little better in our favor, 8 out of 10. I mean, 8 out of 110. All right. So that's the idea of with replacement or without. What's changing, as you can see, is the denominator. So that's what we have to be careful with. So the last little part of video 2, this is not video 2, video 9, is a quicker one. We're going to talk about Venn diagrams. And in Math 122, you probably already talked about Venn diagrams already. If not, a Venn diagram is what? It's circles that are intersecting, and we're able to put the information in to try to figure out, so say for example, maybe a classroom has kids that have cats and dogs, and some have cats and dogs. And we want to know, okay, which percentage is each. So pictorially, it looks like what? We have 2 circles. This is event A, so how many kids have a dog? This is event B, how many kids have a cat? And then where they intersect or overlap is A plus B. How many have a cat and a dog? So let's look at an example how we can use Venn diagrams and how it applies to probabilities. So in a certain school, "40 students take a Spanish class. "60 take a French class. However, 10 take both." So 10 of the students take Spanish and French. And I'm pretty impressed. I'm trying to learn Greek right now, and to try to learn 2 languages at the same time, that's pretty impressive for these kids. So the question we want is what percent of the students take Spanish only? So a common mistake with this is to say, all right, well, there must be 100 kids, 40 plus 60, and 40 are taking Spanish, so 40 divided by 100, 40%. Okay, well this was an easy problem, but it's not because of this caveat at the end. 10 are taking both. So if we use the Venn diagram, let's call this Spanish, let's call this French. So how many are taking Spanish? Well, 40 total. How many are taking French? 60 total. But 10 are taking both. So 10 goes inside here, which is Spanish and French. So if 40 students are taking Spanish, but 10 are taking Spanish and French, how many does that leave over taking just Spanish? Well, that would be what? 30. Because 30 plus 10 is 40 students total taking a Spanish class. We don't really need it, but we can do the similar idea for French. If there's 60 total taking French, but 10 are taking Spanish and French, that means what? That only 50 are taking Spanish alone. So the question is, how many are taking Spanish only? Well, 30 are taking Spanish only. How many students are taking a foreign language? Well, that's our 40 plus 60. Sorry, that's not 40 plus 60. It's 30 plus 10 plus 50. All the students taking a foreign language. So how many total students are taking a foreign language? 30 are taking only Spanish, 10 are taking Spanish and French, 50 are taking French by itself. So we actually did need that for this. So simplify it, we get what? 30 plus 10 is 40, plus 50 is 90. So if you have your calculator, you do this, it's what? It's 1/3, which is 33 1/3%. So it's not 40% taking Spanish only, as the problem tries to trick you into thinking. It's actually 1/3, 33 1/3%. So that's how we can use Venn diagrams if we're trying to figure out statistics, probabilities. We're trying to find out percentages, how many students are taking, in this case, a certain language, how many students have just a dog, etc., etc. So that's it. Like I said, this video was sort of a quick one, the idea of with or without replacement, and then the idea of how we can use Venn diagrams to help us with these types of problems. So come on back, and we're going to start getting into now the idea. We have a little bit more with probability and probabilities, and then we'll start delving into statistics. So come on back and we'll do that.